Hey guys, let's solve question number 2 of LeetCode. Add two numbers. We are given two non-empty linked lists representing non-negative integers. The digits are stored in reverse order and each of the node contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Alright, so what they basically want us to do is this linked list is a reversed number, that is it's 342 and 465. We have to add these and return 807 to them. So the reason they are reversed is it's because it's easier to add this way. We can just pass on the carry on to the next node. We can't do the same in the correct direction. So let's dive right into it. This is the basic definition of linked list in Python. You have class list node. You make a class. You initialize the class with self and a zero value, and the next is a pointer which is pointing to none. If you do indeed end up supplying the node with any value, it will assign it to itself. Alright, so these are the like default values. Before we dive into the code, I want you to understand the logic behind it. Let's keep this on the side. What we have to do over here is, first off, we have to loop through this, right? What we need to do is, currently we are on node 2. All right, node 5. We'll add these numbers, we'll get 7. All right, we need to store the 7 into our result list, linked list. We'll create a new node and we'll point this linked list pointer to that new node. And then we go on to the next nodes, 4, 6. Over here now is the tricky part. You add these two, you'll get 10, right? So this 1 over here will become a carry. So in this linked list, you only store 0, make a new node. In that new node, you'll pass this next parameter, and then you come over here, and in your next iteration, you use this 1 as well as a carry. So this 1 will come over here, 1 plus 3 plus 4, 8. And finally, you return this linked list. But how do you return this? You'll give the pointer to this one. Alright, I hope you guys understood what I'm trying to say. So let's dive right into what we need to code. Okay, so let's start coding this. Again, keep this in mind. We'll keep it on side for now. Let's I, let's reduce this tab. Still want to see this so we understand. Alright, so over here we need to initialize two things. Sum equals to 0 and another carry equals to 0. Alright, total. Right. Once we have initialized this, we initialize a new node, list node 0. Alright, this is our answer linked list. Once we have done that, we enter the while loop to pass through this. Now what would be the condition? While L1 is not null, why is it not taking null value? Uh, My bad. This would be not null. This would be none. While L1 is not none and L2 is not none and carry not equal to 0. Because see, one case can be such that over here instead of 3, 4, suppose we get an 8 over here. So 3 plus 8 will become 11. And in last we have another carry. So we need to make another node 1, which will last node will be need to point out to 1. Also that reminds me, we need to keep uh, the original pointer as well, no? Answer. So this will be answer node and this would be current pointer equals to answer. This answer will stay over here only. The current pointer will go ahead. So while this is the case, we'll perform the operation of total, that is total equals to L1 dot val plus L2 dot val. Alright. Now in this, we need to differentiate with the digit. That is digit would be total percentage 10 and the carry would be total upon 10. So this will take return only integer. So even if the total is okay, where did my paint go? Yeah, even if my total is, suppose my total is 11. So what 11 mod 10 will give me 1. The number that we need to store in this node, and this we need to pass on to as a carry for the next node. So this will get using performing double upon 10. So what this will return is instead of 1.1, it will return me only 1, which we need. Alright. So we have our carry, we have our digit. We assign this digit to current pointer. Current pointer dot val equals to digit. The carry goes on ahead. Over here, total will have value of carry as well. The original carry value is 0, but for the following loops, over here we need to use carry. Huh. So what another case can happen is, how do I, where is the eraser tool? Here it is. Wow. Just wow. How do I increase the size of eraser then? Okay, let's just select this, use the fill tool, and we are good to go. Anyways, I was saying we can have a node like 2, 4, only 2, 4, but the next node can be 5, 5, 1, 1, 1, 1. So in this case, over here it will terminate, and over this part, this third one, it will give us error. So we need to perform a condition, put a condition over here. So what we can do is val 1 equals to this. Alright. If L1 not null, not null, else 0. We'll do this again for val 2. Copy this, paste it over here. Again, we'll do the same for val 2. And over here, we'll add val1 and val2 instead of L1 dot val L. Val1 plus val2. Alright, we have digit equals to total percent. Hmm. Over here, I'm a bit confused. But no, actually, it would be is not none. Is not none. Because the opposite would be is none. So is not none. We are testing for the other way around. So once we have done this current pointer, we need to make the new node. New node equals to list node 0 current pointer dot next equals to new node. And once we have put the next to that, we'll move on to that new node. Current pointer equals to new node equals to actually this. So we'll go on to the next one. All right, let's check. We took val1, val2, digit, carry goes on ahead, current pointer dot val equals to digit, new node equals to we create a new node, put the address to that new node in dot next, and we push the current pointer to the next node. All right, once we are done with this, we go on to move the L1 pointers. We put L1 and L2, both of them to the next one. That is L1 dot next and L2 equals to L2 dot next. Once we are done with this, mm, this would be OR condition or because these things can be none, but the carry might be one. Our last case that we thought of, digit, we put the digit, new node created, push the pointer ahead, push the pointer for the list node, our original nodes as well, and it will loop again. Yeah, we are all set. Now we simply just return, return, simply return the original head, and the original head is answer. This should work. Let's try running this. For which test case it failed? Oh, for this test case it failed. Do we check for none again over here or what? Object has no attribute next. None type. Yeah. I guess over here we need to check for none again. So let's add that to our answer. If oh, why are we are typing it again? Oh, not both of them need to be L1. And over here, else instead of 0, we go else none. Let's try running it again. Hopefully we'll pass the test cases this time around. Wrong answer. What's happening over here is we are adding a new node in the end. We can simply type current pointer dot next equals to. So like what's happening over here is we are creating a new node. So what we can do is instead of new node, we simply type none. So that new node will get disposed of. Let's run this again. Wait, we are already making this go ahead, right? One step ahead. Okay. So what's happening over here, guys, is in a solution, we are creating the nodes over here. If you look closely, before we are assigning the digit and we are not checking if the numbers have terminated or not. We are directly assigning the value. Hmm. A cheeky solution for this would be to pass the result answer string again, answer list linked list again, and okay, I'll show you the solution, the cheeky solution I'm talking about. While we'll assign this as temp, and temp is answer dot next. All right. So while we need to take two pointers, what we'll do is let me show you. We have our linked list. All right, three nodes and one extra node, right? So just forgive the arrows and try to understand. We have answer over here. We'll assign temp over here. We'll check if the next pointer for this temp does point to something or is it none. If it's none, sorry, if it points to something, we'll go ahead. And this will move ahead as well. Now again, this points to something, it will go ahead. And we'll move this ahead as well. Now this doesn't point to anything. So once we have checked for this case that this isn't pointing to anything, we'll do this dot next equals to none. We'll delete this node. So let's do that. I know there must be some better way to do it over here, but I wanna give it a shot, make you understand how you can like pass through the linked list. So we need to have two pointers over here. One is the temp one, and another would be this answer one. While temp dot next is not none. Actually, while temp is not none, because I think in our second test case, yeah, we are if we try to assign this as Yeah, while temp, no, while that temp dot next is not none, we'll do temp equals to temp dot next and last equals to last dot next. Once we exit this loop, we simply do last dot next equals to none. This should give us the answer. I know not the most optimal way because we are going through the linked list again, but it's giving us answer. Let's try submitting it, see if we pass the runtime or do we get error. So, so here if you see the runtime, it's 50 milliseconds. Pretty good performance to be honest. Let's expand this. Okay, my laptop is overheating. Give me just one moment, guys. Anyways, we got pretty good runtime. Anyways, that's it for today's video. I hope you understood the concept of linked list. This question is rated as medium because of this linked list concept. It is easier with Python, but if you try to implement it with other languages like C or C++, you need to use pointers and stuff like declare star over here and stuff. So that's why it becomes harder with other languages. But in Python and Java, we have inbuilt support for linked lists. Not like inbuilt linked lists, but we have support for this pointer over here. That's why we were able to implement it so easily. Thanks for watching, and I'll see you in the next one.